With a Sablas. Today I'm going to discuss some of the problem of electromagnetism. So this is my problem. Before I discuss this, so let's just read the problem. An electron is initially moving at a speed of 1.79 times 10 to the third meter per second directly toward a long wire that has 2 ampere of current flowing through it. The electron is 2.5 meters away from the wire. What is the magnitude of the force exerted by the magnetic field of the electron? So, first thing first, it says that an electron, we got to make sure we keep that in mind because an electron has a negative charge and will behave oppositely that is something that is positively charged. So let me just go ahead and draw a picture of what we have. So first, we draw a carrying current. So carrying current, and we have a value of current which is I is equals to 2 amps. Which is I is equals to 2 amps, and we have this is our current, and we have a distance of a wire. We have it 2.5 meter. This is our distance of a wire. Then we have a electron. Our electron is being projected as the straight of the wire. So this is our electron. This is it. And we have a value of velocity 1 point. This is our value of velocity. And then the distance of 2.50 meter. At this moment, we take a look and the wire is carrying current up. So the wire is carrying current up. Now remember that we're looking at the wire carrying current. So we have this is I. And this is I. Remember that the magnetic field lines around of circle. So if this is your circle, imagine that grabbing wire using your thumb, your finger will be into a counterclockwise. This is it. They're going to a counterclockwise. And the circle that are going around, that's kind of hard to do. This is a two-dimensional plane, but there's like a circle kind of going around. Here. This is a circle that's going around the wire and the moment time. So here what I want you to do, I would just kind of grab the wire using your thumb pointing up. So the thumb pointing, grab the wire. You'll notice that when you point it where the electron is yours. So if you grab the wire using your thumb, so the electron pointing at you. So we're going to the side of the magnetic field for B into. This is our B into the I. This is our B into the I. Just because it's into the board and the side according to the current. current will slip the other way. Next is we're going to determine the magnetic field at a distance of 2.5 meter from the wires. This is what I'm gonna do. We have a B is equals to M of I over the 2 pi r. We know that M is a constant, this is constant. I is the given, that is the current, which is 2 amps, this is the current. And R, this is the distance away from the wire, which is 2.5 meter. And the moment of time, I could plug into that. So we have this. To get the numerical value, we have a F is equals to the absolute value of Q B sine theta plug into the force on the charge moving to the magnetic field. And so remember that the first formula we learned. So remember that the magnitude is just the size of the force exerted by the magnetic field on the electron. So the magnitude is just the size of the force exerted by the magnetic field on the electron. So we have a formula of F of B is equals to Q absolute value Q B sine theta, and the theta here is equals to 1 because our angle is equals to 90 degrees. So we have F of B is equals to absolute value of Q B mu naught I of mu naught I over 2 pi r. So we have a value of charge. We have a value of charge is equals to 1.6 times 10 the power of negative 19 C. So we have a 1.6 times 10 to negative 19 column, and the absolute value. Do not forget the absolute value. And we have a velocity of 1.79 times 10 to the power of 3 meter per second times 2 ampere over 2 pi times 2.5 meter. So if we put this into the calculator, we get a value of 4.58 times 10 to the power of negative 23 Newton. So here it is. I hope that everyone will kanang nakasabot mo of the topic that I'm sharing to you. That would be all. Thank you.